Alright, now moving on to exercise 3. This one was just a little bit trickier than the other ones because you now have some dipping geology. So we've got our strike and dip symbols on here. It's striking in this direction. Remember, the long line indicates the direction of strike, and it's dipping in this case towards the east because that's what this little tick means. And the angle that it's dipping at is 30 degrees. So all of these beds are all dipping at 30 degrees. There's lots of strikes and dips. The reason we have lots of strikes and dips on here is because a geologist has walked across this ground and they've measured the bedding in multiple locations, and wherever you measure the bedding you draw it onto your map. So he's measured it in several places on each beds. Sometimes you'll find that there is only one bed where you can measure bedding, so you'll find that you'll only have one bed that has a bedding measurement, and the other two you have to either infer that it's parallel to this bed, or you have to use some other kind of criteria to figure out exactly what the strike and dip is doing. But in this case we know that they're all dipping at 30 degrees because there are multiple measurements on each bed saying that they're at 30 degrees. Again, you have your cross-section line A, B. This is the first one you had to do, and then there was a second one from C to D that you had to do. So we'll start off with the first one. The easier one is AB. The reason this one is easier is because it is perpendicular to our strike direction. So this angle here is 90 degrees, and that means we can use the 30 degrees, which is our true dip, as the dip on our cross-section. So drawing these cross sections, relatively simple. We said topography is flat, so remember the first thing you do is draw a topographic profile. In this case the topographic profile is just a straight line, and again you don't need a ruler. Try and be more careful than I've been, but you don't need to use a ruler. You've never seen topography that is perfectly ruled flat, I'm willing to bet. I've never seen it, so I'm sure you've never seen it either. So draw it by hand, but do try and be careful. So once you've drawn the topographic profile, which in this case is nice and simple, then it's time to start putting the geology on. So once again, you line up your piece of paper along that cross-section line, and you put your marks where there are changes, where there are geological boundaries. So in this case we have two. We have the boundary between this conglomerate and the sandstone, and we have the boundary between the sandstone and the shale. So then you take your piece of paper, line it up along your topographic profile, put those marks on, which you can see I've drawn on here, and that's where your boundaries are going to be on your profile. The next thing you need to do is put in your dipping strata. So the dipping strata is nice and simple. It's dipping down at 30 degrees towards the east. So remember, this is A, this is B. So once again, this is the west, this is the east of our map, and our strata is all dipping towards the east. You can see that from our dip and strike symbols. So that angle is 30 degrees towards the east. So the 30 degrees is this angle in here. I've used a protractor to measure that so that we can accurately measure 30 degrees downwards. Now I've written 30 degrees on here so that you can see what that 30 degrees is, but you guys don't need to write 30 degrees on there. Just make sure that you've measured it accurately. You don't actually need to write that angle on there. Then you fill in your symbols. I've used the same ones as the map. You still need a key on there. You still need a title on there. You still need some kind of scale on there. You still need to label the axis as height in meters above sea level. You still need to label your A and B on there. So make sure all of those standard components are on all of these cross sections. The only last thing to note is I've drawn this dashed line with question marks down here. That's because this is the limit of our knowledge. We don't know what's happening off the map. We don't know what's happening further towards the west there. This is the limit of our knowledge. So I've drawn a dashed line with question marks along it just to indicate that we don't really know what's happening down at depth here. This conglomerate layer might continue down all the way down to the edge here, but it might stop here, or it might stop here, or it might stop here, or it might stop right on the very edge of our map. So you just want to put question marks down there just to indicate that that is the limit of your knowledge. So the next part of this exercise was just a little bit trickier again. You had to calculate out the apparent dip. You're now drawing a cross section that is oblique to our strike direction. So remember, our strike is going north-south like this. We now have this angle between our strike and our and our cross-section line. So we need to actually measure the angle in here to figure out what our apparent dip is going to be. And the angle that you really need to measure is this one in here. And the way you do that is simply with a protractor. So that's what I've done. I've lined up a protractor. We've got our angle in here between this and this, and you can see that comes out as that's 0, 10, 20, about 29 degrees. And then we use our Woolnough diagram to figure out what our apparent dip is going to be. So our Woolnough diagram, we need two pieces of information. We need the direction angle and we need the true dip. The true dip is the one that's written on our map. That's always going to be the true dip, so it's going to be 30 degrees. So what we do is draw a line across 30 degrees like this. We know our direction angle now because we've used a protractor and we've measured it and we've said that it's 29 degrees. So that's 20, that's 30, 29 is something like this and like that. And where these lines intersect, that is giving us our apparent dip. So we're looking at where it intersects relative to these curved lines that go down like this. So this is the 25 degree line, this is the 30 degree line. Our intersection is roughly halfway between those two curves. So we're looking at an apparent dip of something like 27 degrees, somewhere between 27 to 28 degrees. So then you do your cross section just like you did before. You line up your piece of paper along here, like that. You mark off where those boundaries are. But now when you're drawing your cross section, again you will mark your boundaries onto there, and now you're drawing down an angle, and this angle will now be 27 degrees. So very similar to before, but now it's at 27 degrees. So it doesn't make a huge amount of difference because we've only got a relatively small angle in here. We're not that oblique to our strike line, but imagine if you had a much steeper angle like this, and sometimes it's quite useful to be drawing cross sections obliquely to your strike line. But if you don't use the apparent dip, then your cross section is going to be wrong. It's not going to be an accurate predictive model, which is going to cause all sorts of problems if you're using it to do things like set up drilling programs, which is something that's quite important in mining or oil and gas geology. So that's the two exercises. I'll pause it once again and we'll move on to the